Welcome to our presentation on Automotive Design Analysis. Throughout this presentation, you will learn what automotive design analysis is and how it is transforming the automotive industry. We will tell you about the type of software that exists, who sells it, and which automotive companies currently utilize design analysis software. In addition, we will explain how implementing design analysis impacts the cost and culture of a business, the error rates involved with this approach, and suggest future opportunities that design analysis could create. Now let's take a look at what automotive design analysis is.
In its simplest terms, design analysis is a powerful software technology for simulating physical behavior on the computer. Will it break? Will it deform? Will it get too hot? These are the types of questions for which design analysis provides accurate answers. Instead of building a prototype and developing elaborate testing regimens to analyze the physical behavior of a product, engineers can elicit this information quickly and accurately on the computer. Due to the ability of design analysis to minimize or even eliminate the need for physical prototyping and testing, the technology has gone mainstream in the manufacturing world over the past decade as a valuable product development tool. It has become present in almost all fields of engineering.
If the automotive industry wants to produce products faster, create more dynamic designs, and reduce warranty claim for the customers, one way to meet these goals would be through the use of design analysis. One way design analysis tends to transform the automotive industry is to reduce the time it takes for a product to reach the market. The time reduction happens through the use of 3D models instead of prototypes. 3D models allow for accurate prediction of failure points within the model.
Design analysis also reduces testing costs by using simulations. This approach helps reduce unforeseen failure points or weaknesses in the design prior to production. This results in increased confidence in the product, which provides manufacturers and consumers the peace of mind that the automobile is of higher quality and safety standards. Since design analysis provides the ability to test functions prior to production, the industry sees a reduced number of warranty claims. We will now take a deeper look at each of these components.
Reduced time to market is a major component in how design analysis is transforming the automotive industry. Let's take a look at the comparison of 3D models to prototyping to get a further grasp on how the time to market is reduced. For example, this motor is a component that can be validated. The motor can be tested without the use of actual steel, and the correct properties of the material can be tied to properly predict failure modes. When weak areas are found virtually, modifications can be made to meet the requirements. Simulations can then be rerun to validate changes and prove out the design.
Another advantage of the 3D model is it can be virtually checked for interferences to see if the pieces fit together, but also if interference will occur during operation. Prototyping can also check for interferences, but it takes time to physically make the components to do the testing. Sometimes improving the strengths of a component is all that is really occurring. The hood of this automobile is designed to cover the engine bay. Strength is added to the design so that the hood can take some small, standard, everyday force without having to be fixed or replaced. The picture shows how design analysis would replicate the ball hitting the hood and the shock waves rippling out. By using the proper materials and structure, the hood can regain its shape without permanently being deformed.
In addition, simulation testing within the 3D model allows errors to be fixed early in the design. This results in easier modification to the components and reduced testing. When component errors occur while using prototyping, it's labor-intensive to correct. As we are all aware, not all design even comes to fruition. It takes time to create, inspect, and check for components to ensure a product is ready for the market. If and when that time occurs, the use of automated design analysis greatly reduces the time to bring those products to the market.
The second key component to design analysis transforming the automotive industry is the ability to reduce testing costs. Testing costs are reduced when fewer physical tests are needed due to enhanced design abilities and fewer physical prototypes are required. To show how much design analysis can save, we utilized a program to calculate the potential savings. This chart shows our figures. Our U.S.-based automotive business has a design team of 5 people who will be developing 10 designs over the next 12 months. Our team has no simulation currently on hand to help in their design, and they expect 100 engineering change orders per year. The annual cost of scrap in production is $10,000. Let's take a look at the results.
The graph shows that savings are increased over the years. The blue band represents the improving project lifecycle quality. The orange indicates reduced prototype testing cost. The green depicts improvements in new product development productivity, and the light gray band denotes reduced engineering change order cost. Let's take a look at year 1 in more detail. Total cost savings for year 1 is comprised of the following components: $267 in reduced manufacturing scrap cost, roughly $120,000 in improved new product development productivity, $74,000 in reduced prototype testing cost, $7,800 in reduced engineering change order cost, and $300,000 in improved project lifecycle quality. By implementing design analysis, we reduced testing cost by over $500,000 in year 1. That is impressive.
Design analysis ability to increase confidence in the product is the third key component in how it is transforming the automotive industry. As you have learned earlier, the more simulations that are used, the more confidence one becomes in their design. This car frame is simulating the flex a vehicle has when it is under a lot of pressure, like hard cornering while driving or last-minute swerve to avoid an object. By simulating the different weights of pressure, the rigidity and stability of a vehicle can be improved. This increases the performance of the vehicle and the owner's overall satisfaction.
Simulations can also increase safety by reproducing many hard-to-produce accidents. This simulation illustrates a vehicle sliding broadside into a pole. Design analysis allows a design to use the same simulation but adjust the vehicle's location by a few inches to determine if the damage would be more severe. Physical testing can also do this, but with a much greater expense and costly setup to ensure the vehicle hits the proper location. With a simulation, the speed of a vehicle can be changed with a few keystrokes, allowing results to be analyzed for safety. Hundreds of simulations can be run in the time it takes to produce one car and set it up for destruction. Simulations can produce an overall safer car at a reduced cost for the supplier.
To meet safety guidelines, the auto industry must test their vehicles to ensure they meet a certain safety criteria. Knowing what the criteria is up front allows the designers to ensure, through simulation, that their vehicle will meet the crash standards, thus allowing them to have increased confidence that the first prototype produced will be very close to what is released into production.
The final component in how design analysis is transforming the automotive industry is through reduced warranty claims. Simulations make this feasible through earlier testing, allowing reliability issues to be found in testing and fewer issues in the production. Reducing these problems will lead to an overall reduced product lifecycle cost of the automobile for the manufacturer and the consumer.
So design analysis is transforming the automotive industry. Well, who sells this software? Automotive design software is a highly competitive market with several competitors vying for market share. Autodesk, the makers of AutoCAD, is arguably the most well-known manufacturer of computer-aided design software in the world. Since the introduction of AutoCAD in 1982, their software has offered functionality and innovation few others can match. It is the top choice of professional designers around the world.
ANSYS is another company in the automotive design market. They were founded in 1970 and are located just south of Pittsburgh, Pennsylvania. Although they sell both simulation and workflow technology software, their ANSYS Mechanical Suite is a software that is used in automotive design.
Computer-Aided Technology, Inc., or CATI, is the third company that sells this type of software. Located in Buffalo Grove, Illinois, and founded in 1992, they offer a one-stop full-service solution. The company's software, SolidWorks 3D Design, is used to easily subject designs to the same conditions they would experience in the real world. SolidWorks focuses on ease of use, which allows more engineers, designers, and other technology professionals than ever before to take advantage of 3D to bring their designs to life. In addition to automotive design software, they also have electrical design, rapid prototyping, analysis and simulation, and design automation software.
Many automotive manufacturers are already using automotive design software to save time, reduce cost, and deliver high-quality products faster. Ford Motor Company typically runs at least 5,000 virtually simulated builds on an assembly design rather than building 5,000 prototypes. For example, Ford used automotive design to improve quality when they discovered slightly wobbly radio knobs on a new car model that was just about to be launched. Although it did not impact function, it could have reduced perceived quality. Using design analysis software, Ford pinpointed the culprit. They were able to identify and create another feature to reduce the wobble.
General Motors was one of the first automobile manufacturers to use computers in manufacturing. In the 1950s, they used software to solve complex chemical rate equations associated with catalytic converters. GM continued to be a pioneer in design software use and even developed their own computer graphics system between 1958 and 1967 called DAC-1, which stood for Design Augmented by Computer. The use of automotive design software allows GM to help identify and resolve design faults in their products without expensive prototyping.
Toyota also uses several different automotive design softwares and even created their own system in 1998 called Togo. More recently, they have used Autodesk's Inventor software to create 3D models of truck-mounted crash attenuators to visualize function before creating drawings. This allowed Toyota to reduce their cycle time and become a leaner manufacturer.
Honda is another automobile manufacturer who uses automotive design software. Specifically, they have used it in their SUV designs. Honda found that with the use of software, they could reduce time to market while delivering high quality and aesthetically pleasing designs for their customers while also keeping them safe. The quick digital product design and prototyping allowed designers and engineers to preview all aspects of a car virtually so decisions could be made before any components were physically created.
Chrysler also uses automotive design software as a foundation so they can develop products that meet regulations around the world. Additionally, they use the software to test dimensions and tolerances in components and to evaluate parts before inspection.
888 Race Engineering UK is a top motorsport company. They use automotive design software to design faster while at the same time enhancing their design creativity. It allows them to model conceptually and trial different scenarios early in the development process. Throughout the years, they have increased their use of software and now use design software throughout all stages of product development.
As you can see, many businesses in the automotive industry utilize design analysis for the benefits we have previously discussed. Let's take a minute now to discuss how implementing design analysis can impact the cost and culture of a business. One of the biggest impacts is reduced overhead cost for warranty claims. Remember the problems Toyota had with an accelerator on the Camry model? This issue cost the company in excess of $2 billion in warranty claims. Not only did it impact the bottom line, but it also negatively impacted the outlook of the company. Then the company had a second set of recalls on their steering wheels and cooling systems. Could simulation have predicted some of these issues? Design analysis also helps shorten the time to market by reducing costly prototype iterations and helps produce a higher quality vehicle. This leads to higher consumer confidence in the business and reduces time spent on components changed in the field due to failure.
Error rates can occur in both simulations and in physical testing. For example, simulation error can be caused by an engineer improperly loading information. The advantage to design analysis is that it allows the designer to quickly fix the information and run the test again. However, when the test is run on a physical prototype and incorrect information is used, the testing event is over and it is very timely and costly to replicate. Simulation software is getting more and more sophisticated in reducing the error rates normally seen in the past. In fact, the software has become so advanced that it can find small inefficiencies in the design that physical testing may miss or not produce without long-term testing.
Design analysis not only benefits businesses and consumers today, but it can open up new avenues and create many opportunities in the near future. The creation of new courses in schools that specialize in design, simulation, and analysis is a possibility. As the demand for reducing cost of manufacturing progresses and making them more environmentally friendly increases, design analysis seems a likely solution. With the increase in use of design, simulation, and analysis, there would be an increased demand for courses specializing in this area, thus likely to create a wave of technology institutes and courses centered on this field of specialization. With the increased education around design analysis software, engineers and programmers would have opportunities to develop new and improved simulation and analysis software and improve upon existing software packages.
Now that you know design analysis is a powerful software technology for simulating physical behavior on the computer and how it's impacting the automotive industry, it's not surprising that this field has the potential for tremendous growth over the next 5 to 10 years. It is set to redefine not only the automotive industry, but also the manufacturing sector as a whole.
So, the next time you get into your vehicle, think about the higher quality and safety ratings surrounding you due to design analysis. It's amazing what technology can do.